Thank you all and welcome to the presentation of one of the problem types of GiD, Iber. I am Sanz, member of the development team. I first thank Ernest Blade and Luis Thea, main developers of Iber, and also the members of the team Iber, Esteban Sañudo and Gonzalo Garcia Allen, whom are currently developing Iber within the PhD, their collaboration in this presentation. So, what's Iber? Iber is a free distributed software that born for the simulation of the hydrodynamics in shallow water flows. As we will see, Iber has been growing and currently is able to simulate morphodynamics, hydrological processes, pollutant transport and reaction, ecohydraulics, etc. As you know, Iber and GiD evolves together. The workflow of Iber is fully integrated in the pre- and post-process tools of GiD, some of them being directly developed for Iber and then integrated into GiD and or adapted from GiD to the necessities of Iber. The three main steps define the workflow of Iber. First, a pre-process where all conditions are implemented. Second, the calculation process that is in charge of Iber. And third, the post-process where all results can be analyzed or exported to other softwares. Different developments of Iber have had the improvements of GiD. For instance, the first version of the hydrological model required the reading and the assignation of rainfall rasters to simulate the evolution of a rainfall, such as occur in real events. The urban drainage model needed an important code refactoring to consider the seaweed network in the model as linear elements. For Ibergood, a Lagrangian scheme and mesh were necessary to link the effects of the good log on the hydrodynamics and vice versa. The water quality model usually needs huge amounts of data, such as time series. For the ecohydraulic model, specific boundary inlet and post-process options were implemented to analyze the weight-to-sailable area within the model. And the latest version, which includes important improvements of the existing models and other new models, was developed jointly with the GiD team in order to achieve more robust and user-friendly numerical tool. What's on the latest version? An important change in the interface was done because the number of models and options has increased considerably, as you can see in this image. The main menu is simplified enormously and hydrodynamic and shear stress related terms are shown by default. But how to activate other models and additional options? Easily, through the plugin option. This new window helps the user on selecting the required model and the possibility of performing the calculations with the sequential code or with the GPU parallelized one, which reached speedups of 100 times in comparison with the sequential code. All calculations models are grouped by thematic. For instance, if we choose hydrological processes and soil erosion models, the interface immediately is updated with the corresponding menus and options of each calculation model. The workflow is almost the same, but with this methodology, each project is focused to the objectives of the proper study. Additionally, the style of some windows have been homogenized according to the latest version of GiD style. An important improvement was done in the raster exportation tool. This window was inspired in the View Result window of GiD. Now this tool is able to export the current results on a specific time step or all of them. This new tool is also able to export any result calculated during the simulation or calculated directly in the post-process in a faster, more efficient, robust and user-friendly way than previous versions. Additionally, the results can be exported without being displayed. Currently, we are working on different research lines, always focusing on a more realistic modeling. Reservoirs operations have significant impacts on the catchment hydrology, flood risk, and fluvial processes. However, few available hydrological modeling packages can simulate complex, dynamic, manually operated reservoir control structures. One of the latest line of work consisted on the development of reservoir modeling model. First, the main characteristics of the reservoir are defined, such as the crest height or the storage curve, and then these characteristics are assigned to the geometry or mesh. The reservoir is modeled as a virtual tank in which the volume of water is updated based on the inflow, outflow, infiltration and evaporation processes. On the one hand, it is possible to define the outflow structures of the reservoir dam, as well as a discharge curve defined by the user himself. In the definition of the structures, the discharge equation and the graphic interface of it has been adapted for the correct definition of the calculation coefficients. It is possible to model free overflow, radial gates, vertical lift gates, and outlets. We are currently working in linking Iber with Swim, a stormwater management tool for the urban areas. Iber solves the rainfall runoff processes in the surface, while Swim solves the groundwater flow in the network. Exchanges are synchronized between the two-dimensional domain, calculated in Iber, and the one-dimensional domain calculated in Swim. The development of a high-resolution model of pluvial flooding with Iber Swim implies the definition of roofs in the urban areas, and since their areas and their effects cannot be ignored. Thus, a new dialog is created to define and assign the roof parameters over the surface in one step. Physical parameters of roofs and their connection with the network and the treatment of their discharges must be defined. Additionally, the use of green infrastructures such as roofs is becoming more and more common to mitigate the effects of the flooding in urban areas. Nowadays, hydraulic modelers demand software that can implement these green infrastructures in 2D models. To satisfy that demand, new models to modeling green infrastructures impact have been implemented in Iber Swim. So far, only green roofs can be implemented. The methodology is quite like other elements. First, we must define the roof element by introducing the layer properties, and then a second step, which consists in assigning the roof to the surface or to the mesh. With these inputs, infiltration and percolation processes will be solved. Well, that's all for the model. Thank you for your attention, and if you are interested in Iber, please visit iberola.com.